Okay, let's go ahead and talk about finding the area of regular polygons. Now, what I have here is a septagon. You can draw any polygon that you want. And I went ahead and drew some triangles. I made some triangles by connecting the center of my polygon to the vertices of my polygon. If you need to take a second to go ahead and draw that on your paper, take your time. You could draw a hexagon or an octagon or a pentagon, whatever you want. I chose a septagon because I can have a computer make it for me. And I don't really draw septagons a lot. So that's my polygon. Now, what do we know about regular polygons? Well, we know that all of the angles are the same, and we know that all of the sides are the same. So let's go ahead and mark our sides. Let's call our side S. And let's mark them all congruent. So my side length is S, and all of these sides are congruent. And hopefully you're seeing that if we just find the area of one of these triangles, well, all of these triangles are going to be congruent. So if I find the area of one triangle, well, then I just multiply by the number of triangles that there are, which happens to be the same as the number of sides that there are. And I should have the area of the whole figure. So let's talk about finding the area of one of these triangles. The area of a triangle is 1/2 base times height. So the base for any of these triangles is just my side length S. But the height is something that we call the apothem. The apothem. So let's go ahead, I'll write that down. The apothem. Every time I say that, I feel like I'm saying opossum with a lisp. But it's not an opossum, it's just the apothem. All right, the apothem is this height, kind of. It's the height of this triangle. It's the line that is a perpendicular line to the side, to any side of my polygon that comes from the center. So let's draw it. Oops, we want the line tool, if we can get it. Starting from the center, going down, it's a little bit off. Starting from the center, going straight down. There's my apothem. And of course, it makes a right angle. Oops, let's make that blue if we can. So there's the right angle. It is the apothem, right? That's an A, I promise. So kind of looks like an A with a toupee, am I right? All right, so we've got the apothem. Now the area of a triangle is 1/2 base times height. So in this case, that's 1/2 times the side times my, let's see, my apothem. 1/2 times the side length times the apothem. And if I want to find the area, like we said earlier, the area of this whole figure, well, let's say that, let's call n, let's say that n is the number of sides. That means the area of my polygon is equal to it's equal to n times the area of my triangle. So that means that it is equal to n times, let's see, maybe we just, that's equal to n times 1/2 times the side times the apothem. So let's go back here. 1/2 times the side times the apothem. Sure, we'll keep it colorful. Wow. The apothem. Okay, and I'm going to mix this up a little bit, and we'll just leave it. I'm going to turn it all purple now. That's equal to 1/2 times n times the side length times the apothem. Something you should notice is that if I'm multiplying the number of sides, can I do that with a different color? If I'm multiplying the number of sides times the side length, that's equal to what? Hopefully in your brain you're thinking that's equal to the perimeter, right? That's equal to the perimeter. So then this is equal to 1/2 times the perimeter of my regular polygon times the apothem, right? Times the apothem. And so you maybe even could write that as the apothem times the perimeter divided by 2. And that's the area of the polygon. Yes, the area of the polygon is equal to 1/2 the apothem times the perimeter, or the apothem times the perimeter divided by 2.